Hello, mic test, mic test. Hello. Can you hear me, class? Hello, mic test. Can you also access the Zoom? Can you access the Zoom now?
Present, sir. Paano yun, sir? Hindi kami maalam nun, sir.
Hindi kayo maalam? O, sige.
Hindi po kami marunong.
Okay, no problem. We'll use this BB Collab. Okay. So, kumain na ba kayo ng dinner ninyo?
Hindi po, sir. Hindi pa. Nagluluto po, sir. Sir. Nagluluto pa lang.
Dapat kanina pa kayong nagluto at saka kumain na.
Wala, sir. Mas gusto namin makinig sa inyo. Yun.
Yun. Sana yung iba. Particle, no? Particle moving along a straight line. Okay?
Well, wait lang daw, sir. Wala daw nalabas kay Darrell.
Alright, guys. Let's begin. Good evening, everyone.
Good evening, sir. Good evening, sir.
Okay, so last time we talked about rectilinear motion. Now we have here the illustration. This is a horizontal line. We have here a particle. We assume that the particle is moving along this straight line, and we assume that the particle is initially at this position at point O, and it moves to the right. Okay, with the distance traveled equal to x. So we assume that the distance from this point.
Kung naka-record daw po.
Sorry.
Kung naka-record daw po ito.
Hindi. Kung naka-record, ma-access ba niyo yung recording? Hindi, naka-record to sa ano ko, sa I have an own recording which I'm going to upload later on. Okay?
Sige po, sir.
Okay, let's continue. So, we have here what we call position coordinate. Ito yung tinatawag natin position coordinate. Position coordinate of a particle is defined by positive or negative distance of a particle from a fixed origin on the line. So, you can see here from this line. So, we call it origin. That is the fixed line origin. So the particle movement could be positive or negative. It depends on which direction, no, from the fixed point. If it goes to the right from its original position, so we consider this as positive, or if it goes to the left, so we consider it as negative. Okay? Now the motion of a particle is known if the position coordinate of a particle is known for every value of time t, and motion of particle may be expressed in the form of a function that is for example, in this function here we have x as a function of t equal to 6t squared minus t cubed, or in the form of a graph that is x versus t. So we have here x, the vertical line, represent the displacement or the distance traveled by the particle with respect to time, which is the horizontal part. Okay, so when you graph this function, makikita natin class na graph or drawing ito siya, itong kulay blue. Alright, so next we have so now we will talk about average velocity. So consider the particle which occupies position P. So ito yung particle natin which occupies this position P at time t. Now originally this particle was at this point, the fixed point, point O, and then it travels or it moves to this direction towards the right, and it travels a distance or the displacement equal to x at time t. So it means the time it took the particle to move from point O to point P is equal to t. Now if we consider that the particle is moves farther, going to the right after a certain period of time, or there's a increase of time, and it covers distance delta x, so there's a change of the distance traveled with the particle from this position P to the next position P prime. Alright, now to find the average velocity of the movement of the particle, so we have here the concept that the average velocity is equal to the ratio of the change of the displacement delta x with respect to the change of time, which is delta t. So in other words class, at this point we have t plus delta t. Okay, so ibig sabihin yan na galing dito patungo dito t, then from here to there, that is delta t. So you sum up, no, ang total time spent by the particle from point O to point P prime is equal to t plus delta t. That is, ibig sabihin yan, galing dito patungo dyan, t yan. Okay, the time spent is t. And then from here to there, that is delta t. So total time is t plus delta t. Okay? So average velocity equal to delta x over delta t. And we call the instantaneous velocity v as the limit of the ratio of delta t and delta x and delta t as delta t approaches to 0. Alright, so instantaneous velocity may be positive or negative, and the magnitude of velocity is referred to a particle speed. Please kindly mute your microphone if you are not speaking. Mute lang muna parang hindi masyadong maingay. Okay, so in this scenario class, if you look at this, okay, so we have here velocity could be positive, no, if the particle is moving from this point going to the right. Okay, we have the velocity equal to or greater than 0, that is positive. Alright, now if the particle is moving from this point going to the left, then we can say that the velocity is negative. So you can see here that v is less than 0. Okay, next, so from the definition of derivative, we have velocity, instantaneous velocity is equal to the limit of delta x over delta t as delta t approaches to 0, which is equivalent to dx over dt. It means that the instantaneous velocity is just equivalent to the derivative of the displacement with respect to time, dt. That's why if you have x, the displacement x as a function of time, given as 6t squared minus t cubed, now to find the instantaneous velocity, you just take the derivative, derivative of x as a function of time with respect to t. So derivative of x as a function of t equal to dx over dt, or that is the velocity as a function of time, and that is equivalent to 12t minus 3t squared. Okay, so you just take the derivative of this function here and you will get it here. You will get this equivalent. So that is the instantaneous velocity, and when you graph this, you will see this one. By the way, class, can you try accessing the Zoom?
Sir, hindi po maalam.
No, you just go to the, kasi dito class, ang problema dito, hindi ko ma-explain masyado tong naka-PDF kasi ito eh. But anyway, I'll try to upload the or share the PowerPoint. Kasi merong slide dito na very important na concept dito, but it's in PDF. So I don't know how could I explain it well. Anyway, just go on. We'll just consider one thing at a time. Later on, I will use the PowerPoint for just one particular slide. Okay, so to continue, we have here the result of taking the derivative of the displacement with respect to time. So ito yung displacement natin, class, x as a function of t equal to 6t squared minus t cubed. Now taking the derivative of x as a function of time, we got the derivative of x with respect to t, which is equal to the instantaneous velocity. So ang instantaneous velocity natin ngayon ay represent. Okay, so let's continue, no? So particle moving to the right, okay, particle moving to the right, we have the velocity positive. Okay, v greater than 0 meaning positive. Velocity or particle moving to the left, we have the velocity greater than, or velocity is less than 0 or negative. Okay, so pwede siyang mag-positive ang velocity, pwede mag-negative depending on where's the direction of the movement of the particle. So we have here the concept that the instantaneous velocity may be positive or negative. So ito yung ibig sabihin niya, class, depende sa scenario. And magnitude of velocity is referred to as particle speed. Okay? Now, from the definition of derivative, we have here the instantaneous velocity, as mentioned a while ago. This is the limit of the delta x with respect to delta t as delta t approaches to 0. Then from our differential calculus, we know that the limit of this ratio, delta x over delta t as delta t approaches to 0, this is just the derivative of x with respect to time. Kaya in our differential calculus, we have velocity is the derivative of the displacement x with respect to time. Okay, so we will use that concept in our coming discussions. So assuming that we have the displacement as a function of time equal to 6t squared minus t cubed. Now taking the derivative of x as a function of time, we have here dx over dt. This is the velocity. Then using our what we have learned from our differential calculus, so derivative of this is equal to 12t, derivative of t cubed, that is 3t squared. Alright? So ito yung vt natin as a function of time. Okay? Now if you graph this, no, as mentioned a while ago, ito yung itsura niya, class. Okay? So, when t equal to 0, so we have the velocity 0. When t is equal to 2, ang velocity natin is 12. When t is equal to 4, substitute natin dito. So, 0. When t is equal to 6, substitute natin dito. So, we got the minus 36. Okay?
Okay, sir.
The particle with velocity v at time t and v prime at t plus delta t. So ito yung illustration niya, class. So initially the particle is moving from a certain position. Hindi lang pinakita dito kung saan siya nag-umpisa, but as you can see in the arrow, it goes to the right. Okay, so after sometimes after t equal to t, meaning time t, so ito yung position ng particle with a velocity v. Okay, and then as it moves farther after another time, so we have t plus delta t. So this is now the new position of the particle p prime, and the velocity is v plus delta t. So nakita natin dito, class, na itong maikli na arrow, so that indicates na ang velocity niya mabagal. Okay? Then here, mahaba yung arrow niya, that indicates that the velocity is
Nag-decrease, sir.
so na yan, pakimute mo na ng ano muna. Okay, so ito yung definition ng acceleration natin. That is the change of the velocity with respect to time. Instantaneous acceleration, meaning that is the acceleration at any time. Alright? Now, instantaneous acceleration may be positive. So, pwede siyang positive, pwedeng negative. In this first illustration, okay, so if you look at the illustration at the left side, so again, we have here a small arrow that indicates that the velocity is slower. Then the next arrow is medyo mahaba, so that indicates na mabilis siya. Okay? And then it goes to the right. So in this particular situation, class, acceleration natin is positive. So you can see here a is greater than 0, meaning the acceleration is positive. So ang scenario dito is that increasing positive velocity. So nakita natin na nag-umpisa siya na maliit na arrow, tapos lumaki. So ibig sabihin increasing. So the velocity is increasing and going to the right. So we can say that the acceleration is positive. Okay? First scenario yan. Another scenario, it can also be positive even if the particle is moving to the left. Even if the particle is moving to the left. So you can see here that the particle, so nakita natin dito na yung arrow niya is mahaba, no? Mahaba, going to the left. Tapos umikli. Umikli yung arrow ng V. Okay? So it means that decreasing siya. Okay? Decreasing. But this is still considered a positive because it goes to the right, that which is negative supposedly, but ang velocity niya is decreasing. So therefore, this can be considered as acceleration is positive. So ang net effect nito niya, class, ang acceleration is positive. Alright? So that is the second scenario. The third scenario is something like this. So you see that the arrow is going to the right, meaning the movement of the particle is going to the right. And you see that the arrow for this velocity is mahaba siya, then later on umikli. So ibig sabihin, from higher velocity to lower velocity. So there is a decreasing, decreasing velocity, decreasing positive velocity. So ang ibig sabihin niyan, ang acceleration natin is negative. Okay, that's why we have acceleration is less than 0. Meaning, if the acceleration is less than 0, that means negative. Okay? Now, for another scenario is something like this. The direction of the arrow now is going to the left. So, nakita natin initially, maikli lang yung arrow ng V. Alright? Tapos, tumaas siya. Okay? So we can say that this is increasing velocity. Increasing velocity going to the left. So that indicates na ang acceleration natin is negative. So we have A less than 0. Okay, is it clear, class? This concept, klaro ba sa inyo?
Yes,
So this there are 4 possible scenarios. Remember that because in our coming discussions or in our yung mga problems natin isosolve natin later on, we'll use this concept, class. So you have to be very careful, no, to use the positive or negative values of the acceleration. So we have what we call deceleration, no? If for example there's a car, you drive a car and then you accelerate. So accelerate meaning you change velocity. Alright, from for example, nagumpisa ka lang nagpatakbo. So mabagal yung takbo tapos bumilis. Okay, bumilis. Then nag-constant ang velocity mo, so the acceleration is 0. And then you suddenly take the brake. So nangyari, bumagal ka. So ang velocity bumaba, nag-decrease siya. So you are actually decelerating. Okay? So you are not accelerating but you are decelerating. Okay? So acceleration is negative. So that is deceleration. Is that clear, class? And when you take the derivative of the velocity, then you will get this equation.
Acceleration.
And this is the corresponding graph. Alright? So, yun ang example, class. No? So, if you're asked to graph the function for x versus time, or v versus time, or a versus time, then you have to present this kind of graphs. Alright? And then the corresponding equation for the graph. Now, to graph this, so ito yung mga assumptions natin, ito yung mga value, at t equal to 0, x equal to 0, v equal to 0, then a is equal to 2 meters per second squared. So ito yung sinubstitute natin sa mga equations dito, and ito yung results. Okay? So for different values of t, ito yung different values ng tatlong functions natin. Alright? Okay, let's continue. Now we have a uniform linear motion. So for a particle in uniform rectilinear motion, the acceleration is 0. Tandaan nyo ha, uniform yung ano niya, rectilinear motion. So that means there's no change of the velocity. So that's why the acceleration is 0. Okay? And the velocity is constant. So acceleration is 0, the velocity is constant. So bakit nagiging 0 ang acceleration? Kasi ang velocity is constant, walang pagbabago. Okay? So from this definition, from this formula, we have the velocity is equal to the derivative of x with respect to time. And from this concept, we have the velocity constant. Okay, now if you are going to cross multiply this dt, or you multiply both sides by dt, then you'll get dx equal to v dt, right? And now when you take the integral, or when you integrate both sides, and the limit for the displacement, we have x0, meaning the initial position of the particle, and the final position of the particle, this is x. And in terms of time, we have t equal to 0, and then final time is t. Okay, so integrating, when you integrate the dx, so you get x. Okay, limit, upper limit is x, lower limit is x sub 0. So substituting the limit, you have x minus x sub 0. On the other side, the right side, so v is constant, kaya pinalabas natin siya. Nasa labas ang v, labas ng integral sign. So ang in-integrate natin yung dt lang, right? So when you integrate the dt, so from our calculus, integral of dt is equal to t. Now substituting the limit, upper limit is t minus 0. So t minus 0 is t. Now multiplied by v, that's why you have vt. Okay, so solving for x here, you add x0 both sides, or you transpose this x sub 0 to the right. So you got x equal to x sub 0 plus v sub v times t. Okay, so this is the formula for finding the displacement, or the distance traveled by the particle with a constant velocity. Okay? So remember the condition, class, huh? You got this distance with this condition that the velocity is constant. So you may use this formula. Okay? Now, for the application, problem, we have an automobile is driven along a straight line at 30 miles per hour for 12 minutes. Then at 40 miles per hour for 20 minutes. And finally, at 50 miles per hour for 8 minutes. Now, the questions are the following. What is the average speed over this interval? Next is, how fast must the automobile move in the last 8 minutes to obtain an average speed of 35 miles per hour? Okay, so what are the givens, class? How are you going to approach this or solve this problem?
Sir po. Tawagin niyo ba po ulit sa sir?
Sige lang, titingnan ko lang yung mga names. You type your names lang once na nasa loob na kayo. You can leave na pag nakatype na kayo.
Okay po sir, thank you po. See you next meeting.
Okay, see you. So, study ha. Try to solve the problem. Okay, you're welcome.
Salamat po sir.
Okay, you're welcome. Ingat kayo ha. Keep safe always.
Thank you sir.
Sige. Ingat.